This is Algebra 1, Unit 8, Lesson 8, Word Problems Using Quadratic Equations. Now that we know how to do quadratic equations, guess what? Now we get to do word problems. So don't worry about having to solve them. You know how to do a quadratic equation. Let's just do the setup. All right, the square of a number decreased by 4 times the number is 21. What is the number? Okay, so my number in this case is going to be x. I don't know what that's going to be, so let's use x as our variable. All right, the square of a number. All right, so if I take my number x and I square it, that's actually going to be x squared. Decreased by means minus. 4 times the number would be 4x. Is means equals 21. What is the number? Okay, so this is the equation. X squared minus 4x equals 21. It's a quadratic because it has x squared in it. So how do we solve a quadratic? We get it equal to 0. Subtract the 21 on both sides. So that gives me x squared minus 4x minus 21 is equal to 0. Okay, so now to solve the quadratic, we have to do our double bubbles in our box. We do the box over here on the side. All right, so we have x squared and negative 21. We know this has got to be x times x. All right, what are the factors of 21 that give you 4? Well, 7 times 3 is 21, so if this is going to be 7 and 3, I need this to be negative 4. So this would actually have to be negative 7, positive 3. So that gives me 3x here, negative 7x here. When you add these two together, it gives you the negative 4. So my factors are x minus 7, x plus 3, equals 0. Now that I've factored it, I want to set each factor equal to 0 using the zero product property. All right, solve each one of these for x, add 7 here, so x is equal to 7, and x is equal to negative 3. Okay, now, can I use both of these numbers? Yes, I actually have 2 answers. When you have a quadratic equation, you are always going to have 2 answers. But sometimes you can use the answer, sometimes you can't. This one doesn't specify the numbers have to be positive or the numbers have to be negative. So there are actually 2 answers. You can say x is equal to 7 or x is equal to negative 3. All right, both of those answers will make this equation true. Now sometimes they may say I only want the positive answers or I only want the negative answers or for some other reason, but unless you are asked, use both of the answers in the problems. Okay, our next question is talking about consecutive odd integers. Remember, consecutive odd integers increase by how much? They increase by 2. So my let statement, my first one, is always going to be x. My second one will go up by 2. Now remember, we're assuming the first one's already odd, so the next one would be 2 up from that odd, so it's just going to be x and x plus 2. Okay, now what's different about this kind of problem, this time it says their product is 90. What does product mean to do? Product means to multiply. So this means if I take the first one times the second one, x times x plus 2, it's going to equal 99. Okay, solve for x. Distribute, distribute. X squared plus 2x equals 99. All right, now it's a quadratic. We want it equal to 0. Minus 99. X squared plus 2x minus 99 equals 0. Factor, factor, factor. Okay, so there's my bubbles. I'll do my box over here. X squared and negative 99. X and x. What gives you 99? Well, how about 11 times 9? That gives you 99. So that would be 11 and 9. Now I want it to be positive 2, so it'd have to be plus 11 minus 9. So that gives me negative 9x plus 11x, and that'll add up to 22 or 2x. So that gives me x plus 11, x minus 9, 9 equals 0, x plus 11 equals 0, x minus 9 equals 0. So this one is going to be negative 11. And this one's going to be 9. Okay, so I actually have 2 answers here. All right, now, when I have the 2 answers, does this say it has to be positive or it has to be negative? No, it doesn't. So I actually have 2 answers here. So say x is 9. what does that make the second integer? Well, it would be 9 plus 2, which is 11. All right, or you could also say, what if x is negative 11? Negative 11 plus 2 is negative 9. So if you're asked for the positive answers, they would be 9 and 11. If you're asked for the negative answers, it'd be negative 11 and negative 9. If we're not specified all, the answers are all of them. So there we go. So we have two answers that we can use. Okay, let's try the next question. The area of a rectangle is 30 square centimeters. If the length of the rectangle measures 7 more than its width, what are the measures of the length and the width? Okay, so this is an area problem, and we're using a geometric figure, so the first thing I'm going to do is draw myself a rectangle. Here's my rectangle drawer. Okay, so now that I know that, where'd it go? There's my rectangle drawer. The length of the rectangle measures 7 more than its width. Do we know what its width is? No, so the width is going to be x, but the length is going to be 7 more than that. More than means to add. Remember, more than means add. So this is going to be x plus 7. Okay, now here is the key word. How do you find the area of a rectangle? Area is found by taking the length and we multiply it by the width. Okay, so let's plug in what we have. All right, so we know the area is 30. That goes here. The length is x plus 7. The width is x. Okay, so this is a quadratic, so we have to distribute x plus 7 times x. I'm just going to distribute this way. All right, that gives me x squared plus 7x is equal to 30. Looks like a quadratic to me, so we want to get this equal to 0, so we're going to minus the 30. And that gives me x squared plus 7x minus 30 is equal to 0. I just turned it around. Okay, so now we factor, factor, factor. Make your bubbles or in your box. All right, here's my box over here. So we have x squared and negative 30, x and x. All right, the factors of 30 that give you 7. What multiplies give you 30? Well, how about 10 and 3? 10 times 3. All right, and then I want this to be positive 7, so it would have to be positive 10 minus 3. Negative 3x, positive 10x, add these two together gives me 7, and that works. All right, so my two bubbles are going to be x plus 10, x minus 3. All right, set each bubble equal to 0. Solve for x. X is negative 10, and x is 3. Okay, now we have two answers here. However, remember this is the measurement of the length and the width of a rectangle. Can the length and the width be negative? No, it can't. So we actually have to reject this answer because it's not positive. You can't whip out your ruler and measure negative 10 on your ruler, so that doesn't work. So we can't use the negative answer because this is an area problem. We're talking about lengths and widths have to be positive. So x equals 3 is your answer. Now make sure you go back and answer your question. What's the measure of the length and the width? Well, x equals 3 is going to be the width, and the length is going to be 3 plus 7, which is 10. All right, and notice that area does give you 30. 10 times 3 does equal 30. So sometimes you may get an answer that you can't use. Be very careful to pay attention to what the question is asking and what kind of answers you can have for that kind of question. Okay, we have another rectangle question. The ratio of the length to width in a rectangle is 2 to 3. All right, let me draw my rectangle. Here's my rectangle drawer. Whoops. Gotta stop doing that. Okay. It says the ratio of the length to the width in a rectangle is 2 to 3. All right, now since this is a ratio, that means the length to the width is some multiple of 2 and 3. We don't know what they are. So one is going to be 2x, the other is going to be 3x. Obviously, this is not to scale, but that's okay. All right, it says find the length of the rectangle when the area is 150. All right, so 2x and 3x are the length and the width. Area is length times width, so that means 2x times 3x is going to equal 150. Okay, so 2x times 3x, make sure you multiply carefully. 2x times 3x is 6x squared. Area is length times width equals 150. All right, now this is a quadratic, so I want it equal to 0, so I'm going to minus the 150. 6x squared minus 150 is equal to 0. Okay, can I make these numbers smaller? Yes, 6 does actually go into 150, so if I divide everything here by 6, 150 divided by 6 is 25. Take my word for it, it is. I can show you if you really want to. All right, now this is x squared minus 25 is equal to 0. All right, ooh, what's special about these? X squared and 25, only two terms with a minus in the middle. It's difference of squares. Okay, so to get x squared, this would have to be x and x. And then to get 25, this would have to be 5 and 5. What kind of signs do you have? It's got to be plus and minus, because remember the middle term is going to drop out because there is no, if this is plus and minus, it's going to add up to 0 in the middle. All right, set each factor equal to 0, set each bubble equal to 0. And you get, subtract the 5, you get x equals negative 5, and x, add the 5. X is equal to positive 5. Okay, again, this is length and width, so can we use negative 5? No, we can't, so we've got to cross that one off. So x equals 5 is what we're going to use. But does that answer the question? It says the ratio of the length of width is 2 to 3. Is 5 the length of the width? No, but we use the x to plug it in. So what's the length and width going to be? This is going to be 2 times 5 is 10, and this is going to be 3 times 5 is 15. So your length and width is going to be 15. So we have to use the x to find the answer. Okay, let's do one more, and then we'll be done. Okay, this one's a little more complicated, but we can do it, no problem. A square has one side increased in length by 2 inches and an adjacent side decreased by 2 inches. If the resulting rectangle has an area of 60 square inches, what was the area of the original square? Okay, now this sounds really complicated, but let's see if we can draw ourselves a picture first. All right, first of all, we're starting with a square. Here's my square. And then we're going to change the square, and it's going to turn out to be a rectangle. So let me draw a rectangle as well. There's my rectangle. All right, not to scale, but that's okay. All right, what do we know about the sides of a square? Well, they're all the same. We're looking for the original sides of the square, but we know they're all the same, but we don't know what they are. So what are they all going to be? They're all going to be x. Okay, because we don't know what they are. Because our square has all the sides are equal on a square. So if one side's x, all the sides are going to be x. All right, it says one side is increased in length by 2 inches. So if I took this side and increased it by 2 to make the rectangle, what's the new length going to be? It's going to be x plus 2. X increased by 2. An adjacent side. An adjacent side means a side next to. So we use this side right here. So a side next to that would either be this one or this one. So let me use this one over here. An adjacent side is decreased by 2 inches. So if this side is x, decreased by 2, this will be x minus 2. Again, not to scale, but that's okay. All right, it says the resulting rectangle has an area of 60. What was the area of the original square? Well, if we can figure out what x is from this using the area, we'll know what x is for this problem over here. We can find the area. Okay, so if we know the area of this is 60, doesn't that mean the length times the width is 60? So that tells me x plus 2 times x minus 2 is equal to 60. Okay, what's special about x plus 2 times x minus 2? Isn't that difference of squares? Yeah, you can work it out if you need to off the side, but if you understand the pattern, x plus 2, x minus 2, isn't this going to be x squared minus 4? Yep, there we go. All right, quadratic equation, we want it equal to 0, minus the 60, watch your signs, x squared minus 64 is equal to 0. Oh, difference of squares again. This is going to be x and x, plus and minus, what gives you 64? Is 8 and 8. Set the factors equal to 0. And solve for x. X is equal to negative 8. And x is equal to positive 8. Can we use negative 8 as a length? Nope. So x equals 8 is going to be the side of your square. There it is. And if you want to plug these in, this would be 6. And this would be 10. Area 60. Now the question is, what was the area of the original square? Well, now that we know the length and the width, 8 times 8 is going to be 64. So this is just solving quadratic equations. Just set them up, solve the quadratic equation, and answer the question.